Good day, all of you. I'm Jayakody. Topic of today's presentation is correlations for undrained shear strength and over consolidation ratio for cohesive alluvial deposit along the Kelani Valley using laboratory test and piezocone test. Here is the outline of my presentation. Now I will start with the introduction. The government of Sri Lanka is currently implementing a project for flood and drought risk mitigation investment plans to protect Colombo and its suburban areas from flooding. Under the first phase of the project, preliminary investigation work has been carried out by National Building Research Organization. We carried out 32 boreholes and 63 cone penetration tests along the Kelani River banks from Hangwella to Kaduvela. Figure 2 shows the part of the geological sections developed from the test data. According to Figure 3, the ground investigation revealed that general stratigraphy of the river alignment is alluvial and composed of cohesive and granular materials or a mixture of silt, clay, sand, and gravel, underlain by a variable thickness of residual soil, which in turn is underlain by bedrock. Now I will move on to the problem statement and objectives of the study. Laboratory testing of undisturbed samples, limited number of tests, applicability of in situ test are major difficulties and drawbacks with respect to determining material parameters. Therefore, correlations play a foremost part in providing such parameters. However, continuous feedback of data from local experience to confirm, validate, and even modify the existing correlations are necessities. Hence, the objective of this study is set to evaluate and discuss the applicability of existing correlations on undrained shear strength and over consolidation ratio for cohesive soils in this Kelani Valley region. Now I will move on to the study path. We have carried out following tests during the project and results obtained through these tests used in the discussion. Unconsolidated undrained triaxial test, 1D consolidation test, piezocone test with pore water pressure measurements, natural moisture content, liquid limit and plastic limits. First discussion point is findings from UU triaxial test. The result of 16 UU triaxial tests and index proper test were used in this study. Accuracy of the results obtained from the UU triaxial test to ascertain the pre-consolidation pressure was checked with the correlation of Cu divided by sigma dash V equals to 0.22 for normally consolidated clay and Cu divided by P dash C equals to 0.22 for over consolidated soils respectively. Soil behaves as NC or SOC generally confirms, where you can see the shadow rows, Mercy's proposal, while the results of soil behaving as OC differs greatly. My second discussion point is calibration of cone factor with UU triaxial test results. The value of Cu estimated using corrected cone resistance is one of the most important empirical approaches in the interpretation of CPTU results, where NKT is the empirical cone factor. We plotted NKTU values with respect to the plasticity index values in the plot suggested by Stark and Delashore, where a clear trend is observed of increase in cone factor with PI. You can see the dotted line here. So with compared to the cone factor ranges of 10 to 24, that is the results of our studies, we cannot see any dependency between the NKTU and plasticity index. That means we are seeing an independent relationship between NKTU and plasticity index. Some researchers suggested that NKTU is independent and some others say it has a relationship with plasticity index. Therefore, it is recommended to have more studies on this relationship. Next discussion point is findings from consolidation test. Out of 20 consolidation test results, only 12 test results were used in the study. And here are the results we obtained from 1D consolidation test. In this slide, I'll talk about use of tip resistance values to develop correlations. These two equations are very commonly used in the industry. According to Campbell and Robertson, there is no unique relationship between OCR or sigma-p from the CPT test results. Even if exists, it is poor due to many reasons, as you can see here. H.S. et al. Collected and presented the values from the past studies. In their K versus friction ratio are plotted. According to the figure 6, we can see the range of K values reported in the previous studies. Then a comparison of results from consolidation test and CPT test were carried out. According to this table, it shows that there is a good agreement between the results from normalized corn resistance with the consolidation results for normally consolidated soils and also slightly over consolidated soils. Then we plotted the empirical constant with friction ratio as suggested by Robertson. It shows that average K is about 0.22 for normally consolidated to slightly over consolidated range for very soft to stiff cohesive soil. However, more studies are needed to establish a proper relationship between K versus FR. Moving on with the presentation. Now I'm going to talk about correlations based on excess pore water pressure. Many researchers have shown relationship between excess pore water pressure as shown in these two equations. And Larson and Muller-Bibb obtain a value of 0.29 for KEPP for inorganic Scandinavian clays which varied with the liquid limit. In our studies also, we plot KEPP value with liquid limit. Particularly, finding a reliable OCR value based on pore water pressure could be very useful in a very soft soil conditions. The average KEPP is about 0.22 for very soft to stiff cohesive soils which are found in Kelani Valley. Finally, the conclusions of the study. Calibration of CU with UU triaxial test is possible using method proposed by Mesri. The corn factor NKKU relating the UU triaxial test to the corn tip resistance of CPTU ranges from 10 to 24 and has an average value of approximately 17 for very soft to stiff saturated clays found from Calnivari area. If only NC to SOC soil is selected, the corn factor is within the range of 15 to 24. The corn factor NKU appears to be independent of plasticity index except for soil having considerably high OCR. The average K in the mostly used correlation could be taken to be 0.22 for soil which behave as NC to SOC range or very soft, stiff, cohesive soil, while K is about 0.19 for all soils found in Kelani Valley. The value K slightly increases with decreasing FR as predicted by Robertson. Yet, further studies needed to be carried out to make a strong conclusion in this regard as well. The average empirical constant of 0.42 could be used for soil which behaves as very soft to stiff cohesive soil. However, the statement made by Larsen and Mulabdi needs to be further studied as the plot of KEPP versus LL does not show a clear trend that KEPP varies with liquid limit. Here are the references used in the study. Thank you for your kind attention. We would like to have any questions from the audience, and you can contact us via these emails. Thank you.